Welcome to today's session about immutable operating systems, how they look today and how they will look in the future coming from SUSE. My name is Daniel Rahn and I'm a Senior Product Manager at SUSE within the Business Critical Linux business unit. For this session, I've prepared a short agenda, first of talking about core requirements for immutable operating systems. Then we'll take a look how the current immutable operating system offering from SUSE implements those and what features we provide here already. And lastly, we'll take a look at the future of immutable operating systems from the SUSE product portfolio starting in 2024. Now, very often when we talk to customers, we're getting the feedback that the operating system is just a commodity or it's overhead. And we are trying to actually enable our customers to take a look at the operating system that way. However, that comes with a certain set of requirements that the operating system needs to fulfill here. And for this session, I've isolated 4 of the most important ones. This is not a fixed list here, so those are just the 4 that I've selected for this session. We'll start with easy mass deployment. When we think about digital transformation inside and outside of the data center, then it's clear that operating system needs to provide a means for easy mass deployment. We've known that from enterprise operating systems, they usually provide a way for automated installation, be it AutoYAS, Kickstart, or others. When we go for real mass deployments, then we actually see challenges with that, and they are using pre-configured images that come with a configuration framework for easy mass deployment comes in as an option here. On top of that, we also need to make sure that the operating system has really low maintenance efforts, so it's supposed to maintain itself. Be it with automatic health checks, automatic system tuning, or automated recovery in case of an error. This goes in line with the stability of the operating system, so it needs to be built from a reliable code base with a reliable lifecycle and best-in-class support. It needs to be covered with maintenance and support so that you can get bug fixes and security updates in regular intervals. And on top of all of that, there needs to be a secure software supply chain that enables you to validate that the updates you're installing onto the operating system are actually coming from the trusted vendor and are not sneaked in by malicious attackers. And with that, last but not least, we come to security. Today's operating system really need to be pre-hardened. They need to be created with security in mind. They need to come with the right tools and confinement frameworks and also provide a means for easy attestation, either locally or remotely. Of course, we also need to be able to apply security updates. And last but not least, there need to be security certifications in place for the operating system that show and confirm that the vendor providing the operating system to you really understands the requirements and has implemented all necessary steps in the development and in the maintenance process to make sure you get the security not only on the product itself, but also with the updates that you're getting and with the support. Now looking at SUSE Linux Enterprise Micro, let's see how we implemented that in our current operating system offering as an immutable operating system. SUSE Linux Enterprise Micro is a lightweight and secure operating system platform for containers and virtual machines, and its clear focus is decentralized infrastructures, or in short, edge. It's really optimized for embedded devices and goes as far as industrial IoT and use cases. It's built from the mission-critical SUSE Linux Enterprise code base and features an immutable design enhanced with additional security features that ensure a reliable runtime. We have prepared this product for very long product life cycles. From the start, it comes with 4 years of general support, but we are ready to extend that on request. On top of that, SUSE Linux Enterprise Micro really focuses on low maintenance efforts. We really are striving to go towards zero maintenance of the infrastructure with SLI Micro. And lastly, it's built for containers and Kubernetes. SliMicro really focuses to be a container host built as an immutable operating system, meaning a read-only root file system, to enable customers to really focus on managing their workloads within containers and really focusing on generating business revenue and not so much focusing on maintaining the operating system that runs the infrastructure. With all that in mind, SliMicro is really built for 4 specific use cases here. First and foremost, it's by default a single node container host. We've chosen a container runtime that does not require Kubernetes as a default. But you can extend it for the second use case to use SliMicro as a Kubernetes cluster nodes and run your Kubernetes workloads on an immutable operating system here. We, of course, support the SUSE Ranger Kubernetes distributions, RKE or K3S on SliMicro, but we also support SliMicro with third-party Kubernetes distributions. In addition to using SliMicro as a container host operating system, we also fully support using SliMicro as a KVM virtualization host. And lastly, SliMicro is a perfect guest in the public cloud and enables you to use an immutable operating system for containerized or virtualized workloads in the public cloud infrastructure already today. With SliMicro, you really have everything under your own control. You have a solid foundation for modernization that enables containerization and virtualization. It requires very low maintenance, provides a high security standard, and is itself built on open standards. So there is no vendor lock-in when you choose a SliMicro for your infrastructure base. When we look at how SliMicro can be used and also managed, there we see different options. Number one, you can use a SliMicro as standalone systems, either container host or virtualization host, but you can also run SliMicro in a managed environment, either via SUSE Manager that then manages SliMicro itself, or via Ranger, which enables you to not only manage SliMicro, but also the workloads that are running on top of SliMicro. So there you already have the full stack management capability via the Ranger management solutions. SliMicro itself has 5 key areas in mind that we started the product with, and that are really the focus for our development. The number one is the immutability. So SliMicro uses a read-only root file system as a default, and we've implemented means to apply updates to that operating system using a technology called transactional updates. Building on top of that comes the reliability, the ability to roll back to old snapshots of the operating system in case of an issue, enhanced by a health check daemon that automatically determines whether the system is still healthy or not when the operating system boots up. And the health check daemon then determines itself whether a rollback is required or not. On top of that, we provide hardening. We fully support as a Linux on SliMicro, the framework and the policies, and we focus on providing a minimal operating system footprint with SliMicro compared to generic data center operating systems. We've enhanced SliMicro here with a simple web-based management option built on the Cockpit project. And in addition to that, we provide the real-time kernel on SliMicro included in the standard offering on the 64-bit Intel and AMD platform. The real-time kernel is an optional installation, so you do not need to use it. You can use the standard SLI default kernel with SliMicro, but if you have real-time sensitive workloads to be run on SliMicro, you can choose for the real-time kernel and deploy your infrastructure using that. And with that, let's take a look on the architectures we are supporting with SliMicro. We are supporting SliMicro on 3 different architectures, the 64-bit Intel and AMD, as I just talked about, including the real-time kernel. We also support SliMicro on the 64-bit ARM architecture, and we support SliMicro on IBM Z and Linux One, so the 64-bit mainframe architecture. You can install SliMicro using the manual installation that you're used to from SUSE Linux Enterprise using YaST2 and also automatically via AutoYast. In addition to that, we provide the aforementioned pre-configured images to expedite image-based deployment and mechanisms to configure those images once the images are deployed. For the public cloud marketplaces, our public cloud team provides pre-configured micro images in all three major marketplaces. Talking about image-based deployment, this is a paradigm change compared to how you previously installed an operating system. So you will be getting a so-called raw image from SUSE, which is a file system image that you just deploy to the storage device. And when the system boots, you supply a configuration file to the system, and that instructs the operating system to adjust the configuration, for example, setting the root password, setting the host name, configuring network, etc. We've chosen Ignition for this task here, and we're also providing a web-based configurator. You can find the URL here on this slide. When we talk about mainframe, usually people are very interested why we are focusing an edge system really also on the mainframe. We consider the mainframe an integrated part of distributed infrastructures because many of the workloads in a distributed infrastructure need powerful systems in the backend and the data center, and we want to enable our customers to run the same software stack regardless where a specific part of the distributed infrastructure is hosted, and therefore also provide support for IBM Z and Linux One on SliMicro. And we are collaborating very closely with our colleagues from IBM on this, specifically in combination with a range of products from SUSE and deploying them on IBM Z systems and Linux One. Now taking a deeper look how we implemented the immutable feature of SliMicro. First and foremost, as I mentioned, SliMicro runs from a read-only root file system. We are using ButterFS here as a file system, but we also need the ability to apply updates to that operating system in order to enable the security features of the operating system and making sure that your infrastructure is always up to date and cannot be attacked from the outside or the inside. In order to do that on a read-only root file system, we developed transactional updates, which in detail looks like this. When transactional update runs, it creates a snapshot from the currently running root file system and mounts this snapshot writable in the operating system. Then package updates and configuration changes are installed into this new snapshot. After all packages are installed and configuration changes are applied, this transaction is verified and the return code is checked. If everything went well, then we mark this snapshot as a new snapshot for the next system boot, and after rebooting the system, it is being activated. If anything goes wrong during this procedure, then we disregard the snapshot and throw it away, and no changes are applied to the operating system here. ButterFS is really very space efficient since it's a copy and write file system. So when we allocate a new snapshot, this only requires a few bytes, and the new snapshot only contains the differences compared to the previous snapshot. So it's very space efficient. For configuration files in /etc, those are part of the snapshot, but we've introduced a technology using an overlay file system here to enable those files to be writable during the operating system runtime, meaning you can create new files in /etc and modify existing files in /etc, even though you're working on a read-only root file system. Transactional update will then make sure when it runs to sync those changes with a new snapshot. So whenever you reboot into the new snapshot, or you need to roll back to an older snapshot, the configuration files in /etc are always consistent with the snapshot you booted. By implementing it this way, we did not need to create a new package format, so we could reuse the existing RPM packages from SLI. Also, ISV software that is provided as RPM packages can still be used on SLI Micro, and customers do not need to learn a new tooling for packaging their software. We also have no size limitation for the partitions or the operating system because we do not need to partition the disks here. We just take whatever we can have with Btrfs and then have Btrfs and our update stack handle the snapshot creation and management. This architecture that you see here is also easily enhanceable by plugins you can write and create for your infrastructure. And taking a bit deeper look into the technology features of the operating system now. Let's start with what I discussed earlier. We have the so-called SUSE Edge integration. So we've enabled the management of the operating system and the workloads in our SUSE Ranger stack. So you can now really manage the complete stack from the Ranger management board through a single pane of glass, and you do not need to use different management tools when you use the SUSE Edge architecture. SLI Micro also uses Network Manager for network management, which enables network management from within Kubernetes here, and it also adds support for mobile broadband devices on top of that. With regards to updates and patches, I already mentioned that we need to reboot the system to activate the new snapshot. In order to mitigate that to a certain degree, we provide a kernel live patching functionality and user live patching here. User live patching on SLI Micro is currently still tech preview. Kernel live patching is fully supported. Kernel live patching, however, kind of breaks the immutable operating system feature of SLI Micro a bit. So this needs to be manually activated by the administrator when deploying SLI Micro. A default configuration of SLI Micro does not enable kernel live patching. When kernel live patching is desired, then it needs to be a conscious decision by the administrator. Everybody needs to be aware that kernel live patching really fiddles with the immutable operating system concept that we are providing here. But we think adding kernel live patching to an operating system that is focused on distributed infrastructure and edge makes sense and enables customers a more smooth experience and better security behavior of the operating system. When we talk about security, that's a good point here. We've also added multi-factor authentication support using FIDO keys to SLI Micro here that enables you to really even more lockdown local access to the system, and that it will really require a specific FIDO key for getting access. As I mentioned earlier, we've added an option to enable a simple web-based management of the system. So if it's a remote system, it's very easy to access that using your web browser, given the right credentials, and then perform the administration tasks. We've also added support for high availability functionality for distributed infrastructure and edge deployments using Keep Alive D and HA proxy, and we support the real-time kernel on Intel and AMD system. When we look at using SLI Micro and edge deployments, then it is also required for the operating system to enable an easy and secure onboarding experience. And with SLI Micro, we fully support secure device onboard using the FIDO device onboard standard here. We have a fully integrated as a Linux stack, the framework, and a fully supported policy, and we support remote attestation on SLI Micro using Keyline. On top of all of that, our focus is, as I mentioned a couple of times already, security hardening. So the SLI security modules that we're using in SLI Micro are currently under evaluation for FIPS 140-3, and SLI Micro 5.3 is also currently being evaluated for common criteria NIAP and common criteria ERL4+, which will enable you to really use SLI Micro in the most secure organizations. When we look at the future of the immutable operating system, we see the future of the immutable operating system really to empower digital transformation. But there are some key requirements that we need to fulfill and take a look at when we talk about digital transformation and immutable operating systems. Number one, we need open, broad, and robust platforms. We need cross-cloud capabilities, and we need to build large and open ecosystems here. But more importantly, we need to build a transitional story for the enterprise and provide transformational assistance because there is a paradigm shift when we go from traditional IT operations to digital transformation, which combines IT and OT operations, and also the teams, etc., are combined. So we need to support this journey for our customers and partners. Now, when we try to bring this together, security stays the priority. It will always be the priority when we look at digital transformation. We need to provide isolation and access control, updates and support, and secure supply chain stay the priority for SUSE here. And in addition to that, confidential computing becomes the number one requirement, specifically when we talk about virtualization and using a public cloud, because only with confidential computing, then we can have a secure, trusted, and sovereign platform to compute data in hostile environments. And when I say hostile environments, please be relaxed. Any infrastructure part that you do not have physical access is potentially a hostile environment. And from the operating system level, we need to do our utmost to make sure your operation stays secure, even if you do not control the underlying platform. Now, looking at the future of the immutable operating system, how do we try to address this? We have this under the headline of zero-touch automation. We will be integrating additional self-healing functionalities into the immutable operating system on top of the already existing health tech daemon. We'll enhance the self-management capabilities of the operating system, and we'll work towards zero-touch operations. So really reducing the manual interactions that you currently have to perform. On top of that, we will be working on self-tuning, self-optimization to make sure the operating system automatically tunes itself for the workloads you're running on top of it. This, in combination with zero touch, will really increase your performance and lower your TCOs here. Last but not least, the operating system should be self-explaining, so it should really explain and with help text, etc., what is being performed and what you may need to do here to really offload work from your admin teams. We think that the future for operating systems is workload centric. We think a key point for workloads in modern deployments is that workloads really need to be agnostic on where they run. They should be able to run unchanged on-premise, off-premise, bare metal, or within a cloud provider. And we are convinced that it is possible to enable everything in a way that you don't need to worry where your workload is being deployed. In addition to that, we believe that a footprint reduction really is helpful for all parties, first and foremost for you, because you can save valuable resources for the operating system and use them for your workload. And that also decreases the administration overhead. That together with a reduction in the background noise by disentangling the application layer from a host system, so meaning the workloads run compartmentalized, so either within containers or with some other means of separation. So we are really looking at introducing a separation layer between the operating system and your workload. Containers are a natural example here, but it will not be limited to containers. We are doing that to actually enable to run several stacks in parallel on the operating system without affecting each other or the operating system itself. And when we then take a look at the life cycles, the compartmentalization and separation allows us to provide longer life cycles potentially for the operating system, while we have different life cycles for part of the workloads that are provided from SUSE, and really manage that separated from each other, which will enable us to provide longer life cycles in many areas. And you can update specific parts of the operating system layer independent of others via the benefits of compartmentalization and separation. And this, as I said, this enables us to provide longer service life cycles for specific parts. But it also enables us to separate the hardware enablement and hardware changes of the operating system from the workload. So you could update your hardware and change it without impacting the runtime that is used for your workload. And therefore, you get a lot more flexibility going forward. Now, when we talk about that, the real question is, okay, how does a life cycle look like here, right? So let's take a look at the life cycle for SLI Micro primarily. SLI Micro, as it is in the market, we have 2 releases per year, and we will continue to do that. And each release comes with 4 years of support. Starting next year, based on a SUSE adaptable Linux platform, we will introduce an additional immutable operating system that is really focused on data center deployments and not so much on distributed infrastructures. And that is currently planned to also come with 4 years of general support. So you will have later on the option to choose an immutable operating system for the data center, and at the same time having an immutable operating system in your distributed infrastructure or edge deployments, and really get the benefits of the immutable operating system and the separation between the operating system and the workloads, independent where your infrastructure is run. With that, what you can surely see here is we have all the options in our product portfolio, so you can choose the operating system that fits your needs best. You can use the Linux Enterprise Server, which is really the gold standard for mission critical workloads, or you can use the immutable operating system based on SUSE Alp being released early next year. That will provide the self-tuning, self-healing sequence stable platform in your data center to power the digital transformation, or you can choose SUSE Linux Enterprise Micro with kind of the same feature set for distributed infrastructure or edge deployments and embedded. Now going back to my initial slide, that really means, what does commodity mean for us as SUSE and for you as a customer? Or for us, it means when you consider our operating system commodity, that is actually an award, because it means we have done our job correctly. And with that, thank you for your attention. I'm really looking forward for questions and feedback from your end. Thank you very much.